With great pleasure, I introduce Robin Peraglie, who's talking about Prepare, introducing novel exploitation techniques in WordPress.
Thank you very much. So the mic's working, great. So yeah, hello and welcome everybody to my talk, introducing novel exploitation techniques in WordPress. So first, before we start, we will see a lot of PHP code today. So everyone who's not into PHP, just hang in there and wait for the demos and try to understand the abstract exploitation techniques, and you should have some fun. Okay, so first of all, a little bit about me. My name's Robin. I used to study at the Ruhr University in Bochum. At the same time, I'm a security researcher at WIPS Technologies. We're a vendor of a static code analysis engine. Pretty cool stuff. With that engine, I love to hack web applications. Had some cool bugs there. Lately in Moodle a few weeks ago was pretty cool stuff. PrestaShop as well. Lime Survey, maybe you've heard about it. And at this moment, I want to give a big shout outs to Slavko Mijalowski and Karim Eluagemi, because their research is kind of like the foundation of what we're going to see today. So big shout outs to them. So yeah, first of all, what's WordPress? WordPress is an open source content management system. I think everyone or most of you will know. The interesting thing is that it is used by at least 30% of the web. So for an attacker, this poses a very interesting target, right? You have a very large attack surface, and so if it's interesting for the attacker, it should be interesting for us. So yeah, at the same time, it's written in PHP, very flexible, very strange language, but at the same time, you can do a lot of it with it. But at the same time, it brings a lot of software vulnerabilities, and I think everyone can agree also on that. The penetration testers called out this as well. So yeah, WordPress has an open bug bounty program on HackerOne. So I believe this leads to a decently hardened core. So you wouldn't find any remote code execution or SQL injections very easily in the WordPress application. So I think the question remains for the attackers and for us, how do you exploit this thing? How do you get into it? So yeah. Of course, WordPress vanilla, like the raw WordPress installation, is actually very, very rare. And what people actually do is they install all these cool plugins to extend the functionality and get the fully blown web application they actually want. So for instance, you can install a plugin which brings in these cool sliders and these cool toolbars, or does even greater stuff. So yeah, and of course, this brings up a problem often, because these plugins are not covered by the bug bounty program. So you kind of plug your bug straight into your WordPress instance, and then you suddenly have a very, very vulnerable instance. So yeah, what we're going to do today, we will examine design flaws in the WordPress core, which then lead to exploitation techniques which can be leveraged and exploited through plugins, through many plugins. And we're not going to do a single vulnerability or not look at a single vulnerability type, or not a technique you can only use at the specific plugins, but we're trying to find vulnerability techniques that you can exploit on many plugins, right? It's kind of a general approach. So yeah, in order to understand that, we're first going to, before we do the exploitation techniques directly, we will take a look at a bit of, at the background. So first of all, let's take a look at the security defense side on the WordPress. Of course, we have CSRF tokens, which prevent an attacker from performing actions in the name of an authenticated user. These ones are generated uniquely for each action, so it's not easy to come around that. We have context-dependent sanitizers, which prevent most of cross-site scripting vulnerabilities, but also, yeah, you of course have to use them in the right context. So if you're using the wrong function in the wrong context, then you still have vulnerability. But most of the time, from what I've seen, most plugins, which kind of care a little bit about security, they most of the times implement them correctly. So yeah, what else do we have? We have magic quotes. I think any one of you know magic quotes? Oh, okay. I had a kind of ancient technology. I had a few hard times getting around the magic quotes in my early days when I tried to hack some pages. But yeah, magic quotes are basically, they convert or try to sanitize user input just before it reaches the web application. So even if you had a very vulnerable line of code in your web application, like you see on the slides below. It looks like a plain SQL injection, but actually with magic quotes, this SQL injection is not exploitable because it would escape and sanitize all the single and double quotes and backslashes, preventing us from controlling the SQL syntax and achieving our SQL injection. So yeah, of course, that's not really state of the art, but what WordPress, of course, does is they have prepared statements. But the interesting thing here is that it's a custom implementation of prepared statements. And you might be asking, why would you implement prepared statements on your own? Because there actually exists a PHP extension for which does exactly that, what you want, which is well tested, pretty secure. A lot of people use it. So yeah, the question remains, why would you implement your own? And it turns out, in fact, that the reason is most of the time it's legacy code. Plugins started to use the vulnerable functions. They had this, and now if you wanted to switch to the PDO extension, you would have to rewrite all of them. And no one of us wants to do that, right? So yes, custom prepared statements. What is different? How does it look like? So yeah, very simple use case. Assume you have a very simple SQL query here, and you have user input, and you want to embed it safely into your query. Then you would first of all call the prepare function, pass the SQL query along with it, have these weird placeholders into your SQL query where you want the user input to be embedded. Of course, in the next step, in the query function, this is just sent to the database. So yeah, and if you are now on to try and make some very simple SQL injection payload, then you would definitely not succeed because everything was escaped properly, even if you hadn't magic quotes in place. So yeah, this is now a little bit of the background we have just seen. And what now we will take a look at is the exploitation technique number 1. Is only vulnerable in WordPress smaller or earlier than 4.8.3. But we will take a look at it right now. So you've seen the custom prepared statements, and now you will see the example, what people actually do. This is not kind of what the prepared statements were designed for, and for this reason, it will definitely lead to a flaw here, but we will see that in a second. If you take a look at this small code snippet, you can see that the users actually slide in or slip in another prepare call and try to construct a SQL query by calling prepare 2 times in a row. This means they take the first result of the first prepare, in this case, the blue variable, which is then later used into the second prepare as an argument. And this means that we have kind of a concatenation of prepare statements called a double prepare, which in fact suffers from a SQL injection. And does anyone see the problem here? Okay, I see some people nodding. That's pretty cool. Yeah, the problem occurs when user input contains these weird placeholders themselves. So assume you would add some query parameters to your address bar, and you would just inject this orange part. This is the placeholder you would inject via user input. Then some magic stuff happens. Actually, it is inserted into the SQL query in the first prepare, which yields us the blue variable, which kind of looks like this. And now you can see it's safely embedded right into the SQL query. You do not have an injection here. There's really nothing to worry about. But what happens is, if the other part of the SQL query is appended and now goes into the second prepare, the user input of the rest of our user input is tried to be embedded by WordPress. And what WordPress did, as just before, it embeds our user input into single quotes. But the problem here is that our placeholder was already in single quotes. So we kind of have these two pair. It is wrapped in single quotes, our user input now, the pink part. But you can see there are actually 2 single quotes to the left side and 2 single quotes to the right side, which ends our user input being left not in quotes. And so we can actually control the query syntax and have our SQL injection right there. So yeah, I've prepared a small demonstration, which you cannot see here right now. Let's see. Can maybe shift it around. See it? Okay, so yeah, here you can see if I type anything into this box here, you will see that everything is just inserted right into the SQL query. And if I now go for single quotes, they are escaped properly, right? But yeah, if I now turn on the highlighting, so we can see what is actually in single quotes and what's not, then we can see that we do not have the injection here. But as soon as I inject a placeholder, you can kind of see that the user input is now embedded outside of the single quotes, and we have our SQL injection there, just to show you that. So yeah, that's basically it. Go back to the slides here. So yeah, that was the double prepare. You've just seen it. And of course, WordPress acknowledged this, and they said, okay, we are going to fix this. A lot of plugins use this. So the patch was kind of like to say, okay, we will change the prepare function, and we will change the query function. And whenever user input contains this placeholder, we want to just replace all % signs with a 66-character long unique random string. And later in the query function, we will just turn it back. So if we take a look again at our old payload, we will now see that when we inject any % signs, they are being effectively replaced with this weird random unique 66-character long strings, yielding only those small digits here. And you can see that all our user input is landing safely into single quotes, and we cannot escape it, and the SQL injection was effectively mitigated by this patch. So yeah, you can see it. This was actually our first exploitation technique already. Of course, it is already patched, but I think if you are a penetration tester, then it is very interesting for you, because you can just look out for that. If you always have this double prepare, or you can also think sometimes they use it in a for loop or in a while loop, and they just start to concatenate the old result of the prepares as an argument in the following prepares, and then you have your SQL injection right there. But of course, it's not that cool because it's already patched. So what we're going to look at right now is our second exploitation technique, which only exists because of our first exploitation technique and because of the patch of our first exploitation technique. And if this patch wasn't in place, we wouldn't be able to have our exploitation technique number 2 here. So yeah, in order to understand the second exploitation technique, I want to just introduce you a little bit of background again. We take a look at the WP query object. So if you were on, which you can just see as another way of sending a database query. So if you were on in your WordPress plugin or theme or core, and you wanted to send a database query really quick, you could just construct this WP query object. And you could pass it an argument, and this argument was parsed into a SQL query, which was then executed to the database. And the results of this SQL query and the SQL query itself were then stored as an object property in the WP query object. So fair enough, sounds pretty cool. But the problem was that this database query sometimes in a large WordPress application got very, very slow. So people said, hey, what can we do about it? And WordPress just said, okay, if you have slow database queries and you send them all over very often in a small seconds, and sometimes you have the same result set, why don't you just store it? You can just cache it, and then the next run you can just omit it. So yeah, this is actually the answer of WordPress, and what they recommend you to do. This is an excerpt from the official WordPress codex. They tell you to implement a simple cache miss and a cache set of the WP query object. So in this small code snippet, you can see the cache is arced. Do we have a result started, a result stored in the cache? If not, please construct the WP query object, send the slow database query, take the results, and put them back in the cache. So so the question is, of course, how do we actually put an object into the database, and how do we store our WP query object temporarily into the database? And before you ask, storing slow database queries, or the results of them in the database, again, is not paradox, because if the second query is faster than the first one, then you actually have performance improvements. So this is actually a good idea. Or how we later will see how this is not a really good idea. But so yeah, how do we put our object into the database? WordPress does it by serialization. Very easy. It is serialized in PHP, then inserted into the database. just as a small recap, serialization in PHP is transforming a variable content into a unique and uniform string format. So yeah, you can see it very easily. An integer is just being transformed into I.1. And yeah, this is basically it. So all the information you can see on the left column is with serialized transformed into the right column. And everything on the right column is transformed back with unserialized to the left column. And the most important part about the serialization in PHP is, I want you to take with for the next chapters, is this little number here in front of the string, which is actually meta information of the string itself, which denotes the character length of the string we have thrown into serialize. And if this number is wrong, a lot of errors occur, and we cannot safely transform it back. Just that you have this as a small reminder. Of course, serialization in PHP does not come without a drawback. As we all know, there are PHP object injections. If user input flows directly into the unserialized function, then you can actually sometimes, you cannot directly execute PHP code, and you cannot directly inject PHP code, but you can actually control the properties of the objects you inject. And if that object uses some functions and uses properties in security-sensitive functions, then you sometimes can achieve all kinds of vulnerabilities, from cross-site scripting to remote code execution. So yeah, just a small recap. So what we're going to look at right now is the actual exploitation technique number 2. This exploitation technique is not only applicable to WooCommerce, but is also applicable to a lot of plugins. And I've chosen a WordPress WooCommerce here, because it is actually very popular. It has 2.3 million installations, just to show you how the attack surface really is. And of course, it's just an example, which leads to authenticated remote code execution in this case. But I will have a few words on that. It is just applicable to a lot of plugins, not only WooCommerce. But we will take a look at WooCommerce specifically, because it is a very nice example. So yeah. WooCommerce actually has these cool shortcodes. So the image you see on the slides is actually something you can do after you've installed WooCommerce. So WooCommerce actually is an e-commerce online shop. So if you install it, then you can sell products in your WordPress instance, pretty cool stuff. And it comes with these cool shortcodes, which you can then use in your blog post. So if there were new products, you would just make these weird, looking like a BB code in these bulletin boards, these cool HTML kind of thingy thing, and you would just put it in your blog post, and it would then later, if people view this blog post, it would then be replaced by this fancy HTML product list. And how this is exactly done, we will see in a second. So yeah, this is the function which is responsible for the products list, and you can see that it actually has the exact key points that we have seen a few slides ago, which was recommended by the WordPress codex. And this is exactly what they did. They just had they followed the developers, which recommend good stuff, because this is exactly what the people are doing. So yeah, of course, we will take a look now at what exactly happens. The only difference between the WordPress codex and our example here is that we do not have a static argument to the WP query object, but this time it is actually user input. And this user input comes from our shortcode, which we are using in our blog post, which is then sent to this function here. So, and we see it on this slide here again. So at the top again, this is our shortcode. We can also pass attributes to it. And this shortcode is going to be the argument of the WP query object. And I told you that this WP query object was sending database queries. So it is, this shortcode is parsed into a SQL query. And as you can see, if we are using a %sign into our shortcode, then through the first patch of our exploitation technique number 1, this %sign is effectively replaced with this 66-character long random and unique string. And then later, in the setTransign function, it is then serialized and supposed to be written to the database, which we'll also take a look at right now. So okay, we have this weird shortcode used. Our WP query object was constructed and then contains our SQL query as a property. which is then serialized into this weird string there. And you can see the orange marked part is again our %, which we've used in the shortcode. If it is now prepared into a SQL query to be inserted into the database and then sent to the query function, what the query function actually thinks is that the placeholder, the 66-character long random unique string, was introduced by the previous prepare beforehand, which was actually not true. This 66-character long random unique string was introduced in the WP query object. So WordPress cannot really distinguish where this escape placeholder is coming from. What this actually means now is that for a serialized string representation, there are these small numbers I told you about. And you can see now that, of course, if we replace a 66-character long string again to a %, then the effective length of our string is shorter, about 65 characters. And this means that the small number which is prefixed with our SQL query is now not entirely true. It's not matching anymore, right? It says 100 characters, but indeed it is only 100 minus 65, yielding 35 characters. And we will actually now see how an attacker can transform this erroneous serialized representation into a working and fully blown PHP object injection in a second. So yeah, again, this is our serialized representation. Our user input is embedded right into it. The numbers do not match. How do we get the injection now? Actually, what unserialized will do when throwing this in, it will actually go 100 characters to the front, try to read this as a string, and then see, okay, the blue part now, try to read it in, but it doesn't work because the delimiters do not match. It must be kind of wrong. So what we can actually do, if we control the second property in our serialized representation, we can actually try to control it as an attacker and fix it. So we actually have a working string. The delimiters are now correct. And at the end of the day, we have our PHP object injection. Yeah, and this is pretty cool, I think. And we're going to now see a little exploit demo of it. So again, let's go back here. You can still see it. So yeah, this is actually one of our WordPress posts. You can see it here. We are using this cool shortcode, and of course we are using %, because this was the exploitation technique number 1, the patch of it we have seen. And if we now click on update, we can actually preview the post. Actually here. And we can see that our post contains this fancy product list I've told you about. And this is pretty cool stuff, and everything is working as expected. But if I now go to the products and throw in manipulate the serialized representation to be a correct one, then actually we have our PHP object injection in a second. So yeah, this is what you can see here. Now it makes a little bit more sense to you, maybe. You can see we have a PHP object injection payload right now. And the only thing I have to do, it is now not correct, because there's a small character right in front. And if I remove this character, then it should actually work. The serialized representation is then fixed to a correct one, and our PHP object injection is kind of armed. And what will happen, you can already see some payload there. But of course, we will just take a look at it. And what we have to do right now is press 2 times. We have to refresh the page 2 times. So the cache is first written, and then later, in the second time, it is then read and then unserialized. So let's hope it works. Once, we did it once, refreshed once, and refreshed twice. And there's our PHP info, and we have showed that the exploitation definitely works. So yeah, pretty cool stuff. I think now everything works as expected. We can now, of course, as an attacker, we can inject arbitrary PHP code. We are not limited to a PHP info page. We can do basically whatever we want with that installation. And now you might be thinking, this is not so cool. This is authenticated. We are in the backend of WordPress. But we have found actually plugins. I cannot name them right now because we are completely done by publishing the vendors. But we have actually found plugins which use these kind of which follow the WordPress codex unauthenticated. So you can, as an unauthenticated user, you can do exactly the steps we've seen. Inject a PHP object somewhere and inject percent signs, which then lead to a manipulated serialized representation. So yeah, let's close the demo again, see what we have here. Yeah, closing words. So what does this mean now? We have seen 2 exploitation techniques. The first one was the double prepare, and we have the second one was a PHP object injection in a specific plugin. But this was not applicable only to the specific plugin, but which you can generalize this to apply it to many plugins, actually. So yeah, this is pretty cool stuff. Either developers, of course, I think, try to avoid unserialized. We have JSON encode and JSON decode, and most of the times this should be sufficient. So yeah, and for code editors, you have seen two things. This weird WP query object being cached. If you see this as a penetration tester or as a code editor, then you pretty much know you still have an injection. Also, of course, in the latest WordPress version. So it's kind of a design flaw in the core, which cannot be taken out because of legacy code and backwards compatibility. So yeah, now we could go for the questions, but we are actually not. I think I'm just going to show you one more little technique, but this time just a video, just 1 minute video, showing how we found a vulnerability, a file deletion vulnerability last week, or a few months ago, actually 6 months ago, and it was published by us a week ago. And funnily, it was just patched yesterday. So what you see right now is information which comes right from, which is actually very, very recent and pretty cool, I think. So yeah, let's take a look at how this actually works. It's not really an exploitation technique, but it's a cool bug, and so I want to show it to you. What happens here, an author logs into the backend. It's not an admin, it's just an author, so everyone who can write blog posts. He uploads a specific picture, a specific image, and injects his obfuscated JavaScript secret payload, which is now not so secret anymore because it was just patched. But so yeah, he just gets the exploit parameters right, sets the thumbnail path correctly, because the vulnerability actually occurs because of the thumbnail deletion. They delete the image correctly, but the thumbnail of it, they don't. So what the attacker now does after setting up the exploit, he just deletes the image he just uploaded and can now delete, for instance, the WP config, which leads to a completely fresh installation. Now, as an attacker, you can now completely fresh install WordPress, and you can actually spawn a plugin of your choice. And we have received questions like, how do you wanna install it? You don't know the database credentials. Well, remember, you can actually use external database credentials, and then spawn your plugin at the backdoor of your choice. And you could then open up the administrator's login and make the administrator actually think that this is still his page and make him use it. So yeah, you still have full control over it. So yeah, that's basically it. Thank you very much for your attention. And yeah.
We have time for probably 2 or 3 quick questions, if there's anyone has a burning question they want to ask.
Yes?
It still works in the latest version of WordPress. Why?
No, the double prepare does not work in the latest. If I said it, it was wrong. It only works in the earlier than 4.8.3, yeah. And through the patch, this vulnerability was mitigated, yeah. But the second exploitation technique is actually still applicable. So this is way more interesting, I think.
Any more questions at all?
Thank you. What would be if you would talk to a plugin author? What would be if he or she would do one thing to make the plugin more secure? What advice would you offer them?
Ooh. Ah, that's a good
Besides deleting the project and.
Well, as you've seen, don't use these code constructs I've showed you. This is definitely a no-go. But of course, sometimes as a plugin developer, you don't really know what's safe and what's not. I mean, how did you know, how do you want to know that the stuff they present online on the WordPress codex is not the safest thing to do? It's very hard, actually, for a plugin developer to decide what's safe and what's not. But I think try to stick to what the most people do, try to be conform, and don't use any weird SQL injection stuff, don't use any PHP object, PHP serialization stuff, because most of the times you don't really need it, right? And don't use cross-site scripting, don't achieve cross-site scripting by reflecting user input directly somewhere. It's actually very hard and not easy. Try to minimize everything. Try to think about security, basically. That would be a good start. Yeah, thank you.
One last question, anyone?
Hi. Is any? I mean, you said. I just want to get the statement straight. Is there no chance for prepared PDO statement in the future, or are you aware of any plans?
Well, that's a good question. I don't know if the WordPress developers, I mean, that's the thing that the WordPress developers have to decide, whether or not they're going to do it or not. But I think it's just for the plugin authors, which are not really WordPress developers, just people like you and me, who are just coding their own stuff. I think every one of them would have to rewrite their plugins. Maybe they find a workaround or some hotfix, but I don't think we will see that in the very near future.
Okay, because that seems to be the basis of some evil in there.
Yeah, definitely. The custom database abstraction layer.
Any more questions? One more question. Okay.
So is there a safe way to use that caching technique that WP Query gives you and give it in the codex?
That's a good question, actually. WooCommerce had the same issue. They now also have the WP Query and use it in the same caching scheme. But this time, they don't store the WP Query object directly, as recommended by the WordPress codex. But this time, they will retrieve the blog posts, which are returned by the WP Query object, and extract the information they want. Because you don't have to store everything. You just can store the IDs of the posts, which can then later be retrieved again from the database. So yeah, I think store less. Don't store the whole object, so it's not being serialized internally by WordPress. Store primitive data types, and then you're safe to go.
So you said you found this in multiple different plugins. How have you found the experience working with the different plugin teams to resolve these type of issues? You said it was about 6 months ago. For that, what's like an average time span that the teams are implementing a fix for this type of issue?
Yeah, that's actually a good question. Most of them had, I mean, 6 months is a long time. Or, well, it's more than average, I guess, for these kind of vulnerabilities. So I think everyone has to judge on themselves whether or not this time is justified or not. But yeah, basically.
Thank you very much.
Thank you.